Sinusoidal equations. So we have our problem here. I'm going to read it over once. We'll highlight what's important, and then we're going to graph the relationship they're describing. So you're in a tube in a pool. So, you know, there's you, super happy, sitting in a tube, and the water or the waves are constantly going by you. Okay. The pool is 3 meters deep, and the waves you create are a meter high. The waves are occurring at a constant rate of 6-second intervals. Graph this relationship. Okay, so let's highlight some important stuff. This is supposed to represent a sinusoidal function, and it pretty much can. The pool is 3 meters deep. That's going to be important. The waves you create are 1 meter high, and the waves are occurring at a 6-second interval. So those are our major parts of information. So in order for us to graph this, and we're just going to do a rough sketch here. We're going to go on the assumption, okay, that our equation of the axis, actually I'm going to move this down here, and actually let's draw just on the side what we think this really looks like. So our pool is 3 meters deep, which is actually a really deep pool. Okay, so that should be our water. I shouldn't do that in red. So here's our water, and we're going to say, oh, this is about 3 meters, okay? And there's you sitting in the tub, or tube, not in the tub. Okay, so there's you. This is happening, and what's happening is the waves are a meter. Is that how high they are? Oh my gosh, those are huge, 3-foot waves in a pool. Essentially what's happening is you're having waves that are going up, and then if you look at a wave, it usually comes down the same amount. So they're being created from your little bobbing up and down in the tube. So if the pool is 3 meters deep, okay, so we're sitting on the surface. That's 3 meters above the ground. So this will be our equation of the axis. Let's use this here. We'll do the equation in blue. We'll say that's the height of the pool. So the height of the pool is right here. This is the equation of the axis. And we're going to say that's about 3 meters off the ground, okay? What's occurring, and let's assume you start at this point here. Every 6 seconds, the waves are changed. So let's put a scale of even numbers so we can get to 6. So let's go maybe like 2, 4, 6, 10, 12, 14, 16, 18, 20, 22, 24. Okay, so here's our scale for time. And the waves are actually going up a meter and down a meter. Now these units aren't quite a full meter. So I'm going to have to draw a line to estimate where I think a meter would be. So we'll use maybe the color green here. So we'll say this is up a meter. Let's do it in green. So a meter up is about that high, and a meter down would be about that low. Okay, again, I'm estimating. I probably should have used the actual scale there. So what that means is every 6 seconds our event is repeating. So we're coming back to the middle at every 3 seconds. That's halfway between, okay? And we're either hitting a peak first and then a trough after, or we're hitting a trough first and a peak after. It doesn't technically matter. They didn't specify where we're starting. So it's assumed that our waves are making this type of pattern. They're going up, coming down at 3, hitting the bottom, and then coming back up again. Okay, so the way you can figure out the timing for this, and they didn't quite ask you, but because it's every 6 seconds, we know the middle would be 3. The peak would be between our value of 0 and 3. So at 1.5 seconds, we have a peak. Okay, and then in between 3 and 6, which would be at 4.5 seconds, would be our trough. Okay, and then this pattern would continue. We would then hit another peak, so 6 more seconds. This would be at the value of 9. We go halfway up in between and halfway down. So we're just we're drawing the same relationship over and over again. And they didn't really ask us for the times in between, but that's the information we can get. These are huge waves, by the way, for somebody who's sitting in a pool in a tube here. So this would essentially be the graph. What's important that we realize that from our question that the period of the waves is 6 seconds, which we've drawn. So every 6 seconds, our relationship is repeating, and we decided to start in the middle. The equation of the axis is supposedly in line with where our tube would be sitting in the pool. And the pool is 3 meters deep. Okay, so if the waves are a meter high, what would be our max value here? How high up are the waves going? What's this value?
4
Yeah,
meters?
4 meters. So we have waves that are above 4 meters. And then when they hit their low point, how low are they? What's our minimum?
2 meters?
That's right. We're at 2 meters here, okay? So it's not like it's going through the bottom of the pool. The bottom of the pool is all the way down here at the y value of 0, okay? And that would continue on and on and on. As for an equation, if they asked you to build an equation for this, if you recall with the equation, we usually write f of x is equal to a sine x plus d. Oh, sorry. Do you guys use h? You use h, right?
Yeah.
Minus h plus k. So let's talk about this. H and k. Now, technically, now in your course, I know they don't really go into this. The period of this for a sine function is technically 360. So we couldn't really use sine. We'd have to multiply by some k value. Okay, we won't really talk about that idea. But just to recap, the amplitude, okay, and what would the amplitude of this wave be? They told us in the question. How high up and down was it going?
1.
1. It's going 1 meter from the equation axis up and 1 meter down. And the amplitude is always our a value, so a would be the value of 1. And the equation of the axis is what value we discovered?
The middle?
Yeah, the middle. So what? But how high up was the middle?
3.
Yeah, so the k value is the equation of the axis, so that would be 3. And as for our functions shifting left and right, they didn't really tell us if we're starting at the top, the middle, the bottom, the middle again. They really didn't tell us, so we can just assume that this is value of 0. That's not really important. And again, technically the period, there is one more value they don't talk about in your course, but they do talk about sinusoid functions called a k value. And there would be a k value that would horizontally compress this, because normally it takes 360. 360 would be way out there, right? So it takes 90 before we hit a peak of a value of 1, right? That's for specifically this function of sine. You guys don't do with it, so we're not going to worry too much about it. Okay, so there's an idea of what the graph of that would look like. So just to show you what our wave would look like if we had graphed it, here's our sine, right? Our a value is 1, our k value is 3. We said h could be 0. And if you notice, right now we're in degrees. Like we said, we started 0, 3. Here it's saying 90 seconds. So this is where our period is off. We knew that the peak was at 4. That's why I have a line there. Our trough was at the value of 2. So again, 270. That's not right for our timing. And the equation of the axis was our value of 3. So we'll kind of turn that off. So here's our wave. Our problem is this period is occurring every, oh, I got to turn this back on to get an actual bell. 360 seconds. That's not quite for us. What we need to do for a k value, okay, we need this to happen every 6 seconds. So I need to take 360 and divide by the value of 6, just a shortcut to do this. So if you get out a calculator, 360 divide 6, and you're going to get the value of 60. Our k value, and I know you don't work with it, but your k value, so the number you're going to put kind of outside here, is going to be 60. Okay, so we go back over and we type the number 60 in here, and you're going to see the period changes. It's much, much faster. So let's zoom in. I'm going to change the scale really quickly to, oh, I don't know, 5 and 20 maybe. Okay, that's a bit better of a scale for us to look at. And if we look now, we start at 3, and our period now happens every 6 seconds. So we went from 0 to 6. So we now changed the period of the function. Again, you guys don't really work with it, but it's something good to know for, who knows for what.